In Unit 10, we're going to look at functions and what it means for a relationship to be a function. We're going to look at a lot of different properties of functions. We're going to look at some different graphs. Um, and we're really going to first just start off with determining if something is a function. Then if it is, how do we evaluate it? So for this first lesson here, we have some important vocab words to start with. So the first thing we have is what we call a correspondence or relation. So this is any kind of set of ordered pairs. So anytime you see an X and a Y, those two elements are related to one another. So a relation is just whenever you have ordered pairs or an X comma Y, so two elements that are related somehow. The function definition is going to be the most important definition. And what a function is, it's a correspondence or relation between these two sets, so between x and y, but it has to follow this rule. So each element of x has to be mapped to one and only one element of y. So that means another way of thinking of this is each input has only one output. So that means in some relationship, my x value can only go to one specific y value. It can only have one corresponding y value for that one x value. So two other important words here are going to be domain and range. So domain and range. Domain meaning all of the input values. So the input are also the x values. So these are the x values. So those are the elements that we can put into this function or into this rule. And the range is what you get out. So it's the output values. So if you think about if you plug x into an equation, what you get out is the y. So the y is the range. Or all possible y values is the range. So before we actually get into looking at equations and graphs and those kinds of things, what we're going to do is we're just going to look at some different scenarios. So in order to do that, well, the first thing we have to know is how to define a function. So what we're going to do is we're going to use this notation where we're going to let f or some letter represent the function name. So typically you use f for function, but it doesn't really matter. And then in the set notation brackets, this would be your set of inputs, and those are going to get mapped. So we use an arrow to represent map to your outputs. So these would be whatever your outputs can be. And you're going to see examples with how this notation is used. But typically it's the name of your function, colon, in the curly brackets, the set of inputs getting mapped to the set of outputs. And then you write a sentence that defines the rule. What is this relationship doing? What's this function doing? So you would be assigning each input, so whatever the input is, so this would change, whatever the input is, to one output, or to an output. And again, you would actually say, what am I assigning to what? It wouldn't be input and output. Those things are going to change. So basically, this top part here is telling you your domain and range of the function. Where this bottom part is telling you the function rule. So it's telling you what to do. So that's actually how you would define a function. So if you look at this next example, this is a scenario where we could actually go through and we could define this using the function notation or using this definition if it is a function. If it's not a function, then you don't want to do that. So the first thing we have to do is decide, is this scenario represented in example 1, is it a function? Does it satisfy the definition that each input only has one output? So in this example, it says, is the assignment of students to lunch periods? So we're going from students to lunch periods, an example of a function. So for me, the easiest way to think of this is I'm asking myself, does each student only get assigned to one lunch period? So this really depends on what grade the student's in. So if you think about our students, um, if it's like a freshman or a sophomore, then they're only going to have one lunch period. But seniors could have multiple lunch periods. So let's just kind of represent this scenario so that you can visually see it. So we have our students, and we are going to assign them to lunch periods. So let's say I have, let's just write student A, student B, student C. So these are just random students that we're picking to just look at. And that's probably good. So I'm going to say that student A is a 9th grader, 10th grader. How about another 10th grader, junior, and senior. So lunch periods. Think about the lunch periods we have. We have 5th period lunch, we have 6th period lunch, and we have 7th period lunch. So each of these students, so obviously there's more than what I have listed here, but each of these students have to go to a lunch period. So let's say we have this 9th grade student has 6th period lunch, this 10th grade student has 5th period, this 10th grader has 6th period, this 11th grader has 5th period, and this senior has double lunch. So let's say they have 6 and 7. So now looking at each one of these students going to a lunch period, we have to ask ourselves, does this satisfy the definition of a function? So if you look at this spot right here, I have this student going to 2 outputs. So this input has multiple outputs. So that's violating the definition of a function. Every other scenario is completely fine because this 9th grader is going to 1 lunch. This 10th grader is going to 1 lunch. This 10th grader is going to 1 output. This junior is going to 1 output. However, this input has multiple outputs. So the answer to this, is this a function? Well, no, it's not a function because of that senior. Now, if we took out the consideration for double lunches, then yes, it would be a function. But because in our school we have double lunch, we're going to leave it in. So we're going to say, no, it's not a function because some seniors or inputs have multiple lunch periods, which are our outputs. So because you have one input that has multiple outputs, that violates the definition of a function. So basically, we don't have to worry about this other part for this example because it only told us to do that if it's a function. So let's look at just a couple more of these. So on the next page, this example is given to us using that definition notation. So instead of just giving us the scenario written out in words, we have a little more here where it says h is the name of this function. So notice how h is right here. That's the name of the function. And remember that these are the input values and these are the output values. So basically what this is saying is h is going to be this function that's going to take student ID numbers and it's going to map them to grade levels. So the inputs are ID numbers, the outputs are going to be grade levels. And the rule that you have to follow, so here's the rule, is that you're going to take each input, which is the ID number, and you're going to assign that ID number to the student's current grade level. So it's going from ID numbers to grade level. And if you think about it, the student ID numbers are really representing the students. So you're assigning each student to a grade level. So let's just look at kind of a mapping here. So we have, let's say, ID number 1, ID number 2, ID number 3, and ID number 4. So these would be our students. So this is just 4 students. There's their ID numbers. And we want to map them to grade level. So let's just do this for high school. So it would be 9, 10, 11, and 12. So if we go to map ID number 1, so this student here, let's just say, okay, this student is a 9th grader. That's it. You can't be in both 9th and 10th grade. Let's say student 2, or this ID number 2, is a junior. That's it. I can't map that to multiple grade levels. I can't map this student to multiple grade levels. And the last one, let's say I map it to a senior. I can't map these to multiple grade levels because each student is only in one grade. So you can keep this list going of possibilities, but it's always going to end up that each student can only go to one grade level. So in this case, yes, this is a function because each input only has one output. There's only one answer for each of these inputs. So yes, because each ID number only has one grade level. And then the next thing here is the domain and range. So the domain, remember, is all of the input values. So the domain is going to be all of the ID numbers. So I'm going to put it in the curly brackets here because it's going to be a set of ID numbers. So this is just going to be the ID numbers that are going to be using numbers 0 through 9. Using numbers 0 through 9. So if you wanted to make up ID numbers, you would use the digits 0 through 9. Now you don't have to put that using numbers 0 through 9, but it's just being more descriptive. And then the range is going to be the grade levels, which in this case, we're saying we're just going to do this for high school. So the range, the only possible outputs is 9, 10, 11, and 12. That's what everything got mapped to. Where the inputs, I could have definitely more inputs than what I listed, but I can't have any more outputs because there's only 4 grade levels. And there's however many kids in the school, that's how many ID numbers I have, which I don't know, so we're just leaving it as, in general, ID numbers, not listing them all out. And then let's look at part C here. So Johnny says that this is not a function because every 9th grader is assigned the same range value of 9. The range only has 4 numbers, 9, 10, 11, and 12, but the domain has a number for every student in our school. So we have multiple inputs here, but only 4 outputs. So he's saying this is not a function because we could have this scenario. So what if I went back up top here and I added in an ID number 5 and I said, okay, well, that person is also a freshman. So now he's saying that because I have 2 inputs going to the same output, that it's not a function. But he's wrong, so explain why he is incorrect. The reason why he's incorrect is because the definition of a function just says that each input can only go to one output. So if you look at this one input, it's going to one output. If you look at ID number 5, it's going to one output. It doesn't matter that they're going to the same output, it just matters that each of these inputs basically only has one line coming off of them because it can only go to one thing. So, let's just say, so Johnny is incorrect because a function, or because the definition of a function is a relationship in which each input has exactly one output. So it's okay for an output to have multiple things coming to it. It's just we have to have each input only going to one thing. So this last example here, we have some more scenarios, just again trying to decide if these are functions. So if you get stuck and you can't figure them out, the best way to do it is just kind of like make up these scenarios like I'm doing with these mappings, so that you can kind of visually see, does each one of these things only go to one output. So for example, if I'm looking at this one, US citizens, so the order does matter here. So US citizens, 2 social security numbers. So would each one of these only go to one of these, is what it's asking. So would each citizen only have one social security number? And yes, a US citizen, their social security number is unique. Each person only has one of them. A US citizen can't get mapped to multiple social security numbers. So yes, this would be a function because each citizen only has one social security number. And if you look at the next one, so this one's saying the residents of a house, so all the people in a house, to the street address. So if you have some house, that's going to be unique. There's going to be a unique street address to represent that house. So this would also be a function because even though there's multiple people in the house, so let's say you have a whole family in the house, you might have 4 people that are going to that same street address. But if you look at each individual person, they would only have one street address. Now there's situations where you could say, well, no, because some people have parents that are separated, so they might live partially with their mom, partially with their dad, so that one person might actually go to 2 street addresses. So in that case, it wouldn't be a function. But I'm going to go with saying, okay, well, if we have these people that live full-time in this one house, they only have one street address, which would mean it is a function. So I'm going to say yes. So basically with this one, you can kind of go either way. You just have to make sure that your explanation backs up with whatever reason you're giving or with whatever answer you're giving. So I'm saying yes because I'm saying that each of these residents only has one street address. Yes, because each resident only has one address. Okay, so then the next one here, the assignment of zip codes to residents. So if you think about a zip code, so think about your zip code. Could that go to more than one person other than you? And the answer is yes. A zip code goes to multiple people. So one zip code is going to go to multiple residents, all of the residents that live there. So that means since this one input could have multiple outputs, it would not be a function. So this is no, not a function. Each zip code could have multiple outputs or residents. And the last one here, what if we flip the order? So now what if we say residents to zip codes? So again, assuming that each person only has one permanent address, so they're living in one house full time, they would only have one zip code. So wherever I'm living, I have one zip code, and that's it. So this would be a function if you flip it, because now we're talking about the one person having a zip code or having the one zip code. So you're going to have multiple residents all going to the same zip code. But that's okay because when you look at is it a function, you're looking at the input. So I'm looking at one particular resident and it's only going to one thing. Every one resident only goes to one zip code. So yes, this is a function because each resident only has one zip code. And again, if these confuse you, just draw out the mappings like what I did up here. Just pick a scenario, draw out those mappings so that you can easily see those lines. So think about when you draw them, how many lines can I draw off of each person? And that kind of determines, is it a function or isn't it?